Hello and welcome to the Daily Space for today, October 2nd, 2018. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. In today's top stories, we have a tale of black holes in collision. Astronomers have long known that as galaxies merge, the supermassive black holes that occupy their cores must merge as well. As we look about the universe, we see system after system that shows all signs of being a merging galaxy pair, but only shows signs of a single supermassive black hole in the center. Work done at Rochester Institute of Technology now helps us understand why. In research that was done to try and model across multiple different kinds of observational detections what a merging black hole should look like, astronomers have realized that these merging systems probably, share one singular outer accretion disk of material that we're able to detect, but deep in its core, this singular accretion disk hides two black holes that each have their own smaller accretion disk. In this research, they've worked to try and understand what high-energy particles might be coming out of this kind of system that can get detected at particle detectors. What kinds of electromagnetic light, what colors of light that aren't visible to the eyes might be getting emitted from these systems. And of course, they've worked to show us just how will gravitational waves be created as these black holes merge. This kind of astronomy, where we're detecting things across gravitational waves, across light, and across particles, is called multi-messenger astronomy. This is a kind of science that has only been possible, beginning in the past couple of decades as we've begun to do neutrino detections of things like supernova explosions and gamma ray bursts. Now, with LIGO, we're also showing that it's possible to detect things in gravitational waves as well. As we move into the future, it's work like this that is being done at Rochester Institute of Technology that shows us what we can expect across all the different kinds of detectors that we use to study our sky. And hopefully, with these kinds of "this is what you shall see," we'll be able to build more and more instruments and put together more and more surveys that will uncover, supermassive black holes in the process of merging, and to detect them both before and after these mergers take place. Now, in other far-out galaxy news, I have a story of stars on the run. As astronomers look out across the sky, we're able to observe the motions of stars both in the plane of the sky, where we see them, relative to the telescope, moving north, south, east, and west. We're also able to observe them using what's called spectroscopy. This allows us to see the specific fingerprints of light that are emitted and absorbed by the various elements in stars. Every atom has its own specific fingerprint of what colors of light it will absorb and emit, and molecules, they also have these same particular patterns. Since we know where the lines should be that are absorbed and emitted by individual kinds of atoms and molecules, when we look at stars and we see these fingerprints of lines, we're able to say, okay, so this line that I see at this one particular shade of red, I'm currently seeing it at a different shade of red. And this tells me the star is on the run. The way that it says this is the same way that we're able to tell that an ambulance is moving towards us by how the pitch of its siren is changed, and tell us when that same ambulance is now moving away from us by how the pitch of its sound is changed. With light, it's the squishing and expansion of the wavelengths of the color that occurs. So as a star moves towards us, its light gets shifted towards the blue. And as it moves away from us, its light gets shifted to the red. Exactly how much the light is shifted is directly related to the speed of these stars. So using spectroscopy, using this effect that's called the Doppler shift, we're able to measure how stars are moving in and out of the plane of the galaxy. This means that through careful observations, such as those that we're able to take with the Gaia spacecraft, we're able to measure stars' three-dimensional motions. We're able to measure how in the sky they're moving north, south, east, and west, and how through the plane of the sky they're moving towards us and away from us. By combining all of these different measurements, scientists working with the Gaia dataset have been able to uncover hypervelocity stars that are moving at the kinds of speeds that indicate, well, they just might have the opportunity to either fly all the way through our galaxy or escape on their way out. We'd long known that these kinds of stars existed, but we haven't been able to detect that many of them because these are just really hard to make measurements. You have to have very finely tuned instruments, and you really do have to have orbiting spacecraft to measure the motions to the north, south, east, and west in the plane of the sky. With Gaia, we finally have the ability to make these fine-tuned measurements. And what astronomers expected to see was a whole variety of stars that were getting flung out of our galaxy after having a close encounter with either the supermassive black hole in the center of our galaxy or with other high-mass objects through multi-object interactions. These kinds of interactions, it's like the gravitational boost that we give to spacecraft to accelerate them on their travels throughout our solar system. If you have that same kind of interaction, but instead of with Jupiter with a black hole, an everyday star can get accelerated in the same physical way that we accelerate spacecraft, but at a much different scale. Well, as Gaia team scientists looked through their data, looking for these hypervelocity stars flying away from our Milky Way, they did indeed turn up roughly 20 of these hypervelocity escapees. What surprised them, though, is they also found a myriad of stars that are moving at massive velocities, but are moving into our galaxy. This wasn't something we had expected, and in trying to understand what could have caused these systems to exist, astronomers are predicting that, well, perhaps these are stars that were stripped out of the Large Magellanic Cloud and are now falling into our galaxy, or perhaps these are objects that came from another galaxy altogether. Or maybe they have a closer to home origin and are simply stars from the halo of our own Milky Way, stars coming in from the outermost regions of our galaxy that are simply coming in towards the center at a pretty high pace. Exactly what is causing these hypervelocity stars to be moving inward? Well, it's too early to tell, but as Gaia continues to observe the sky and continues to release dataset after dataset, astronomers will keep on this mystery and work to try and solve the case of where are the invading stars all coming from. Now, in one final story for today, we have a tale of, well, waiting to see who calls us and asks to be our friend, or more likely, who is leaking radio waves that we are able to detect here on the planet Earth. The Meerkat radio array down in South Africa is an array of 64 different radio antennas. These observational dishes are used to measure everything from cold gas permeating our galaxy to looking at jets coming out of, well, quasars and active galactic nuclei in the farthest reaches of our universe. These radio dishes also have the ability to listen for the kinds of radio signals that astronomers predict might be coming from systems that possessed advanced civilizations. The Breakthrough Listens survey is a new survey that Meerkat is going to do in parallel with all of their other scientific surveys, where the data they collect in this case will be used to, well, listen for other civilizations that may be out there among the stars. This is going to run in parallel with all of Meerkat's other science projects. But what's amazing to me is how they're finding ways to use these dishes for multiple purposes and follow not just the up-and-coming science questions of tomorrow, but also the human questions of, are we alone? And I look forward to seeing the science that comes out of Meerkat, and I'm also going to be watching to see just what else they may see out there, well, all across our galaxy. So that's it in today's stories, and I am now here to take your questions. So please go ahead and at me in the chat. I'm afraid that for some reason the chat is not showing up in the video today. I'm not sure what's going on, but I expect that I had a power outage right before the show went live, and that may have affected something. So looking through the questions, I see a new name, Kristari Zorbarov. Welcome, and if you can at me in the future, it'll make it easier for me to see your questions, but this time I caught it. The question is, when are we going to get a signal? It seems so depressing that we can't detect anyone out there. It would be so sad to never find anyone else. I can't answer your question. What I can tell you is I firmly believe, and this is a belief, that in the next decade, missions that are exploring worlds throughout our solar system will have the ability to either find or rule out simple forms of life on other worlds, whether they be moons like Europa or the briny water beneath the surface of Mars. Once we start to understand how common the formation of life may be, it will start to give us an indication of how common life might be out there on other planets orbiting other stars. Right now, we don't know how common life is. And without that understanding, it's impossible to predict how common civilizations are. And how long civilizations might last is a question, well, we have no way of answering at this point. There is a famous equation, the Drake equation, that can be used to work out the probabilities of other civilizations being out there and being detectable. And unfortunately, we can't solve that equation without having to guess at too many values. So I agree, it would be depressing if it's nothing more than a whole lot of empty space out there. But I can't tell you when we're going to be able to find something. I wish I could. Thank you, Disillusioned. I'm glad that we're able to bring you these streams. I will be here again tomorrow, and things might get a little bit more disjointed because I will be in Australia for about 10 days, and I'm going to be working to find other people to fill in for me. So expect to see Dr. Andreas Plazas and Dr. Matt Richardson filling in. So I will be gone until Monday, October 15th, leaving Wednesday afternoon after the recording of this show. So Hanny Zwerverp is asking, would all these stars have been born near Sagittarius A star? That's the black hole in the center of our galaxy. Could we learn about the composition of that area of the galaxy from their chemical signatures? So, unfortunately, stellar interactions and other things that happen over the multi-billion year course of a galaxy means, or life of a star, means we don't always know exactly where a star formed. So when we see these hypervelocity stars, they could have formed somewhere else. In general, when we look at things that are orbiting near the core of our galaxy, we see that they are more enriched with heavy atoms. We call these metals in astronomy. It's hydrogen, helium, and everything else is metals in our nomenclature. We see things have a heavier metal content when they're close to the center of the galaxy. This is because it's a high-density area. Stars live, die, reform within this environment, and metals just get recycled onwards. Unfortunately, More details in terms of what that supermassive black hole might have. Well, it's as old as the galaxy, and it's been feeding for a long time. And I don't think we can get that particular information back out of the black hole. So, yeah, there's so many things we just can't answer. That's 2 Trucker Kev. It is coming up on 20 years for SETI at Home. So SETI at Home, for those of you who don't know, is a project coming out of the University of California at Berkeley that allows people to use their screensaver, the downtime on their computer, to run through data that has been detected by various people, looking to see if they can find signals out there from the nearest stars. So are there any other questions? I will have a meeting that I need to run to in about 10 minutes, so today's episode is going to have a firm ending. While you continue to type in those questions that you may have, I'd like to remind you that the Daily Space is a production of CosmoQuest. We put on a whole variety of different things, ranging from our daily podcast series, 365 Days of Astronomy, to programs to get you engaged in helping to map out other worlds. Everything can be found over at CosmoQuest.org, your place to learn and do science. Click on over and find out how you can be part of, finding the scientifically interesting places on other worlds and defining where exactly we can safely land a spacecraft. Check out our podcasts and, find out about all the different programs we have going on that you can get involved in. Also, give this channel a follow. Find out when we're going to be going live next. We have all sorts of different content coming to you from all of our partners. Currently, we have people working out of the Astronomical Society of the Pacific, the Planetary Science Institute, and Youngstown State University. Thank you, Trucker Kev, so much for those bits. Can we light up the chat with some rockets? So Hanny is asking, would hypervelocity stars have their planets in tow, or would those be ripped off? So they should still be gravitationally attached if whatever interaction caused those stars to, have those velocities allowed this to happen. Now, the reason I'm phrasing it that way is if these systems that are falling into our galaxy are things that didn't undergo nearby interactions, it's possible that the planets were able to maintain stable orbits. But if it was a close interaction between stars, those planets could also have been stripped off. They could have been flung off at their own high velocities in new and complex directions. So all sorts of different outcomes are possible. It all depends on exactly how the interaction occurred. Sorry that I can't be specific. Today is the day of many things are possible. And this is perhaps another way of saying science is more creative than the human mind and will find ways to do things more interesting and inventive than we will necessarily predict. It is amazing how full and empty space manages to be all at the same time. That's very well said, Hanny. Are there any other questions out there? If not, I am going to need to sign off and go to my next meeting. Although I have to admit, this is one of my highlights of the day, and I'm very grateful for all of you showing up and being here to learn some science. Just as a quick recap, tomorrow I will be back at 1 p.m. Eastern, and that's 6 p.m. London and 10 a.m. Pacific. Tomorrow the show will be followed by Dr. Matt Richardson, who will be bringing you Astro 101. I will then be off to Australia for a 10-day trip. If you'd like to see me, I will be giving talks in both Melbourne and Sydney. So thank you all for being here. Thanks for supporting CosmoQuest, and Well, thanks for your love of science. Um, I'm sorry that you're here late, Zinc. You're just going to have to go back and watch this on the video on demand. Thank you, Bad Panda. Thank you, Guido. Thank you, all of you, Dave Killians, every one of you who is out there. And I hope to see you tomorrow, wherever you are in the world. Have a fabulous morning, evening, or afternoon. And remember, go outside and look up. Bye-bye.